5. Hence, work done we can write as 25, which is equal to half into m into v square. Mass is 2 multiplied by v square. If we simplify this, we'll get v square as 25, and the value of v comes out as 5 meters per second. Going back to the options, the right answer is in option A, 5 meters per second. A block of mass 16 kilograms is pushed and released along a rough surface at an initial speed of 2 meters per second. The block travels a distance of 16 meters and is brought to rest. We have to figure out the frictional force that brings the block to rest. So let's solve this question using both methods. Method number one is the work energy principle, and then we will use the Newton's equations of motion, which are also called the Stewart equation. So method one, work energy principle states that the total work done is equal to the change in kinetic energy, which we can write as final minus initial. Now, initial speed is given as 2 meters per second. So, initial kinetic energy, let's write that half mv square, mass is 16 and the speed is 2 square. So, the initial kinetic energy will come out as 32 joules. But the final kinetic energy, we can write it is 0 because it is mentioned that the block comes to rest. So final kinetic energy comes out as 0. So the change in kinetic energy will be 0 minus 32. Hence, we can write down the total work done will be equal to negative 32 joules. Now, to figure out the work done, we have to figure out what is the net force acting on this object. For that, let us draw the free body diagram of the object. So the weight of the object 16g will act downwards, which will be balanced by the normal reaction, and then we have a frictional force acting towards the left. Now, since n and the weight are cancelling out, so the net force acting on this object is only friction. So let's write down the basic formula for work, Fs cos theta. F here will be friction. Now, the distance traveled is given in the question as 16 meters, and the angle will be 180. Why 180? Because the friction is left and the box is traveling towards the right. So displacement is right, and that is why the angle between displacement and force is 180. So this will be equal to negative 32. So let's simplify. F into 16 into cos 180 is negative 1. And if we simplify this expression, we will get the value of friction as 2 newtons, which means A is the right answer. All right, let's solve this question using the Stewart equation, method number two. So the equation is v square is equal to u square plus 2as. Final speed is 0 because the object is at rest, comes to rest. Initial speed is given to us as 2 meters per second. So we will write 2 square plus 2 times the acceleration multiplied by distance is 16. Now, if we simplify this expression, we will get the acceleration as negative 1 upon 8 meter per second square. So this is the value of acceleration. What do we do after this? We have to figure out the acceleration using the Newton's second law, which states that acceleration will be net force divided by the mass. Net force is only friction acting on this object. So friction divided by m. And mass is 16. So the value of acceleration is F upon 16. Rather, F upon 16 is the magnitude of acceleration. Hence, we can equate both the magnitudes. So F upon 16 will be equal to 1 upon 8. And if we cross multiply and try to figure out the value of friction, that will come out as 16 upon 8, which is 2 newtons. Hence, option A is the right answer to this question. So here we have a motor which is using a cable to pull a trolley up an inclined plane, but at a constant velocity. This is the keyword. So constant velocity means kinetic energy will stay constant. Which of the following statements about the energy changes are correct? So if we look at the three statements, the easiest one to analyze is statement number 2, which states that the total of kinetic and potential energy of the trolley increases. Is that right or wrong? Some students deduce that the total energy, which is called mechanical energy, which is nothing but the combination of kinetic and potential. So mechanical energy is always conserved. That is why option 2 is incorrect. That deduction has a slight flaw in that. So when we say mechanical energy is conserved, that is only conserved when no energy is lost to the environment, which means there are no resistive forces in the system. So there would be no friction, no air resistance, and that is why no energy is lost out. So in that case, we can say initial total energy will be equal to final total energy. But in this case, the trolley is being encountered by a downward friction. So mechanical energy will not be conserved. So the total of kinetic and potential energy being conserved, that's a wrong statement. But still, we need to check, is the statement to right or wrong? It states that the total of kinetic and potential of the trolley increases. Kinetic energy, first of all, is constant since the velocity is constant. So let me write kinetic energy is a constant. Whereas potential energy, the formula for potential energy is mgh. Now, as the trolley is going up, it is being lifted up, which means the value of h is positive. So potential energy is definitely increasing. Hence, the sum total of kinetic and potential also will increase. Hence, we can say statement 2 is definitely correct, which means now if you look at the options, we can eliminate option B since it does not have the statement 2. Statement 1 states that the work done by the engine has a greater magnitude than the work done by friction. Now, there are various ways to analyze it. So, we will start by drawing the free body diagram of the object. So, let's start. So, what will be the different forces acting on this object? One will be the weight of the object, mg, acting downwards. Then we have the normal reaction going this way. Tension will act up the string. Now, this tension is the result of the motor. Since the motor is doing the pulling, so we can say tension is nothing but the engine power. Apart from these forces, we have a downward frictional force, which will be acting down the plane like this. And now we can use the work energy principle, which states that the total work done by all the forces acting on the object will be equal to the change in the kinetic energy. And since in the question it is mentioned that the velocity is constant, which means the change in kinetic energy will be equal to zero. So all we need to do is figure out the total work done. So there are four forces acting here: normal reaction, tension, the gravitational force, and friction. So let us write down the total work done will be work done by the normal reaction plus work done by T, tension, which is the engine power. So WT stands for the work done by the engine. This plus work done by the friction plus work done by the gravitational force. Now we have incorporated all the four forces acting on the object, and the sum result will be equal to zero. So let's write this is zero. Now the formula for work done is Fs cos theta. So this can be used to, let's say, figure out the work done by normal reaction. So the normal reaction is this way, and the trolley is going up the plane. So if you analyze, the angle between the normal reaction and the displacement is 90 degrees. So the work done by the normal reaction is taken as zero because theta is 90 and cos 90 is zero. So work done by the normal reaction is equal to zero. So now let us write down the eventual expression. Work done by T, T, although it is tension, but the source of tension is the motor, which is the engine power. So instead of WT, let me write down the work done by the engine plus work done by friction plus work done by the gravitational force. This is equal to zero. Now, if I go back to the statements, the statement one was the work done by the engine. We have to figure out the work done by the engine. So let us make WE as the subject. So we will get negative WF minus WMG. And let us make negative common. So we'll write WF plus WMG. Now, if we take the magnitudes only on both sides, so let's take mod on both sides. So the negative sign we will ignore. So the work done by engine will be equal to work done by friction plus work done by the gravitational force. These are the only the magnitudes. Hence, we can deduce that the work done by the engine is greater than the work done by the friction. Since the in the equation we have WF plus something, the engine work will be greater than the frictional force. If I go to the statement 1, it states that the work done by the engine has a greater magnitude than the work done by the friction, and that is what we proved. Hence, statement 1 is also correct. In statement 3, it is saying the gain in gravitational potential energy of the trolley has the same magnitude as the work done by the engine. This is definitely not right. So, this statement would have been correct if there are no resistive forces acting on the trolley. So, imagine a case where friction were absent. In that case, the gain in GPE would have been equal to the work done by the engine. And to sum up, remember to solve questions like this, mechanical energy is always conserved if no energy is lost into the environment, which means no resistive forces are acting on the object. But if frictional forces are present, then we use the work energy principle, because that formula also takes into account the work done by the frictional forces. And hence, now if we look at the options, statement 1 and 2 are right. So option A is the right answer.